shop drawings.
Shop drawings. That's my specialty.
Yes, it is. Yes, it is. So we did the tender process. We made the tender document. We did all this discussion. We had the bidding process. We evaluated qualities, time, performance of the system, budget, and now we have a contract.
Yeah.
Nice. So there's a new partner in the game who's now really going to build what we wanted. So we have 10 documents aside. We have all these nice drawings. As we discussed with the tender document, we decreased the amount of information here. So we do actually know a lot more, but now the contractor came with a certain system and he knows more about this system than we know, at least he should. And then he's going to redo this because he's not having this as a document for really manufacturing his facade. He needs a new setup, which is called shop drawings. And these are shop drawings. It's actually shop drawings you did.
Yeah.
And when I look at them, and when I look at, say,
just to explain, because I not only teach, but we also at the office as a facade engineering, and we also did the shop drawings for the contractors, the facade contractors.
Yeah.
So actually,
first we worked as facade consultants,
where we try to leave as many things open as possible, and we make vague or less informative or less information in there.
General system work.
Besides, that's when we work for the architect, and now I switch paths.
Different project, different companies.
Project. So therefore, now I'm working for the shop drawings for a facade contractor. So therefore, I am actually drawing highly detailed the facade, how it's actually going to be built and fabricated.
So when we look at this, we're going to do a close-up in a minute.
Yeah.
This is a lot more information. So when I exactly look at this, it says the exact precise dimensions of the IGUs.
We have the IGU in here, so we know exactly from the building physics and everything like that. We already had everything inside there, and we make sure that the glass...
All information is known.
Yeah.
This, the stick system, which is a certain stick system, which is now defined in here with all the data of the catalog of the stick system integrated.
Here you can already see the little insert aluminium profile to construction-wise stiffen the system. That's the one we've seen at the headquarters with Schüco. Mm-hmm. The little insert material, that's actually used here because it's a long span. Here, dotted lines, for instance, you can see already the fixation that with the shoe that is used to secure it with the plate
to the
concrete that is dotted in here. So there's even the installation and the mounting hardware is seen.
And I see you even define typology of anchors, of screws, of fixings with its performance in this detail. So all the information which you need for manufacturing the system is given here. In what kind of software is this done?
We've done that in Athena. This is a plug-in for AutoCAD. Mm-hmm. It's a software package on its own which allows a facade engineer to make these highly detailed facade drawings with ease and speed. Because in this case, I made, I think for that project, 75 of these shop drawings just in this scale, and then we had overview plans and whatsoever.
Another one.
Here you can see, for instance, these softwares, they make it easy to have the insulation fitting perfectly. We can have the metal that is set here, these cassettes. You type in the thickness of the material, 3mm aluminium, and then you just draw a polyline, and then it already makes the right curvatures, which later is also connected to the production machinery, the metal bending, the metal cutting, and with all the different geometries, that unfolding of these profiles is already included, because these drawings will be then later exported also for the company to make their life easier in the machine hall.
So there's first purpose is to get all the information in. Second purpose is to, say, pre-organize production.
Yeah.
So these data goes then directly to the different types of production which are...
It's sometimes even so that I have to know exactly what the machinery of the contractor is, because he may have certain machines that work with the one or the other technology, where I know that bending radius or whatsoever are different. What's also interesting is that all the products are already here described, because then we know exactly that this is the sunshade.
This is the product.
This is the product. It's not a sunshade, but this is the sunshade we have chosen that is within the offer, and we know exactly where the engine is, and then I can also plan the wiring. So therefore,
here we see the wiring.
There's also be careful here, watertight
true.
whatsoever. This is really this is my most fun part,
This is
because
what you like most.
this is what I like the most. But whenever you change something, you have to change a lot, because there's every plug and every sealant and every film and every water barrier and whatsoever is described. I even described here, this is for instance a HPL facade cladding. We even defined here how the miter cuts are done on the angle in order to perform a very sharp corner detail.
Appearance, yeah.
And this is something, everything is in here.
All the information, and obviously you also have, say, a section and the main plan
Yeah,
elevation
horizontal
to
section.
define.
And this is sometimes also, there's also one that is just half a meter in front of it or left of it, because the geometry of the building's construction site, this is a prefab concrete element, and there was already a casted concrete which has a little bit of different geometry, so you also have to take this into account, because the guys at the very end have to know the differences of the assembling on site or the...
This is a lot of information. This is brought into a detail. Changing it will be a nightmare, because then the changes directly end in other details as well. The nice part with the shop drawings is main geometry is given, system is given, all the products are known.
Yeah.
So information is fixed. It's just organizing that the geometry you need is really possible to be produced.
Yeah.
That's mainly it.
But I also have to mention that back then when we draw that was not so much intelligent as it is right now with BIM, Building Information Management. So therefore nowadays these software tools also have a reference to the, let's say, to the structure of it. The moment the structural engineer changes something on the concrete wall, it already changes in here, and you can get a warning. You can also make more adaptable components that the facade is always attached to that corner, and then when the corner moves, the facade also moves. So therefore, it's a little bit trickier to set it up, but there's a lot of automation integrated if you are able to manage that. And that is the very end, who manage the main data files.
Who manages what? Which brings me to another super important aspect, the process of the shop drawings. So, we did as engineers this. We have a company who's now serving as the company who's going to build it. They do the shop drawings. So you did the shop drawings. Then I, as the engineer, receive these shop drawings, and I have to prove and I have to evaluate them. So I have to make sure, okay, this fits qua performance to what we wanted.
Yeah.
This fits qua system performance to what we wanted. And this fits qua geometry what we want. Size, color, whatever. And then I actually need to sign, I agree on this shop drawing.
Yeah.
Then the shop drawing goes back to the company who does the manufacturing. They need to change if there's things to be changed. This is normally a kind of conversation situation where you need a process. And then after it is controlled and approved there as well, it goes into production.
Yeah.
Then this production process happens. Important here is, this is to be done before production starts. So tender process, contract given, shop drawing process needs to directly get in to start, because that needs some weeks, maybe months, depending on size and geometry and availability of people, and then production can start. So tender process till production still has a gap where these shop drawings are to be done. And then you need to organize, as say the team which is going to build, that this process works well for the construction company, that they can produce the things they need to produce first, and then other parts to be later. This is why we sometimes see at construction sites that huge areas are already filled with facades, while corner detail, for example, not solved. So we know we can solve that, but this is later because we mainly have to do, say, the largest parts in the first shot.
Yeah, it's also, if you look at the density of information, you can already see that this drawings, even with specialized softwares, takes more time. Mm-hmm. So therefore we had actually, in this case where we worked for the facade contractor, we also work on other projects than on the architect's side, for instance, helping him to develop the details. So therefore there's sometimes, I know what the others also struggling with and back and forth. And we had even on the side of the facade contractors, moments where the architect called us, hey, we need to change that. He said, oh, have you been on the building site? It's already built. Mm-hmm. So, but we need a door in there. It's not a facade only, but okay. Then you have to call and then see what is possible. Yeah. That is the moment where it really becomes expensive.
That's the moment when, say, process get a hiccup.
Yeah.
And when process get a hiccup, it's in the end going to cost time. That means money.
Yeah, precisely.
So, shop drawings.